continue linear equations in one variable. Solving equations, reducing equations to linear equations. Recap. Linear equation in one variable. A linear equation is an equation for a straight line in the form of ax plus b, where a and b are real number and x is variable. So, example 3x plus 2. Some important points related to linear equations. There is an equality sign in the linear equation. The expression on the left of the equal sign is called the LHS, left hand side, and the expression on the right of the equal sign is called the RHS, right hand side. Left hand side is LHS, right hand side is RHS. In the linear equation, the LHS is equal to RHS, but this happens for some values only, and these values are the solution of these linear equations. Now, solving equations having the variable on both sides. As the equation can have the variable on both sides also, so we should know how to solve such problems. In this type of problems, we need to bring all the constants on one side and all the terms having variables on the other side. Then they can be solved easily. Solving equations having the variable on both sides. Example, find the solution of 2x minus 3, 6 minus x. Solution. Step 1. Bring all the terms including variable x on LHS and the constants on the RHS. Here 2x minus 6 bring to LHS as plus x. Minus 3 bring to RHS as plus 3. Here sign will change while changing the position of the terms. Step 2. Solve the equation. 3x equals to 9, 2x plus 6x is equal to 3x, 6 plus 3 equals to 9. Step 3. Divide both the sides by 3 to get the solution. Here 3 into x, so we divide. 3x by 3 equals to 9 by 3. Answer is 3 get cancels. 9 by 3, here 3 on the 3, 3 3s are 9, so x equals to 3. Now, linear equation in one variable. The present age of Rohini is 2 times the present age of Ravi. After 5 years, their ages will add to 40 years. Find their present years. So, we convert this word problem into linear equation in one variable. Here Rohini and Ravi. Which is bigger? Rohini is bigger. Now we will take Ravi's age as x. Why? Because the present age of Rohini is 2 times the present age of Ravi. So age of Rohini is related to age of Ravi. So we should know first age of Ravi. So we will take Ravi's age as x. Here in the table, present age Ravi is x. So Rohini 2 times of Ravi. So 2 into x. After 5 years, their ages will add to 40 years. So their ages first. We write their ages after 5 years. So Ravi's present age is x. So after 5 years is x plus 5. Rohini's present age is 2x, so after 5 years 2x plus 5. So, and given that their ages will add to 40 years. So x plus 5 plus 2x plus 5 equals to 40 years. X plus 5 plus 2x plus 5 equals to 40 years. First, so x plus 2x, equals to 3x. First we should add variables terms and another terms. It is given that the sum is 40 years, so equals to 40. So 2x plus 2x equal to 3x, 5 plus 5 equals to 10, and as it is 40. We transpose 10 to RHS, here LHS, so plus 10, so it goes to RHS with sign minus 10. So 3x equals to 40 minus 10, then 3x equals to 30. Here 3x is there, so we should put only variable at LHS. Remaining numbers, remaining constants, remaining coefficients, anything we should transpose right hand side to know x value. So 3x, so 3 into x, so we divide r into transpose as divided by, so 30 by 3. So 3 ones are 3 tens are, so 10 is the answer. So x is equal to 10. Then what is the age of both? Ravi equals to 10 because age of Ravi is x and Rohini age is 2x. So 2 into 10 and 20 years. Right. Solving an equation algebraically when the variable appears on both sides. In previous, only one side is there, variable. Here, both sides. Let us learn. Solve the following equation. 4 of x minus 3 plus 12 equals to 15 minus 5 of x plus 6. Here LHS is x and RHS also have x. Solution. Apply standard algebraic properties. 4 of x minus 3 plus 12 equals to 15 minus 5 of x plus 6. Here first we use distributive property. 4 of x minus 3. So 4 into x, 4x plus minus minus 4 to the 12 plus 12. RHS equals to 15 minus 5 of x plus 6. So 5 into x, 5x minus plus minus 5 into 6, 30. We should multiply distributive property with symbols. First you should multiply symbols and then variables and constants. Here minus 12 plus 12 is equal to 0 and here constants 15 minus 30. So 15 minus 30. So one is plus and another one is minus. So subtract them. Here 15. So symbol is minus because greater number symbol. 30 symbol is minus. 4x equals to minus 15 minus 5x. Here RHS have x value. So we move minus 5x to LHS. So here minus. So change to RHS plus 5x. So 4x plus 5x equals to 9x. Then x is equals to here 9 into x. So it will transpose as minus divided by 9. So minus 15 by 9. So get cancelled. 3 table. 3 3s are 9 denominator. 3 5s are 15 numerator. So minus 5 by 3. Reducing equations to simpler form. Reducing equation is a method for rewriting the equation in a simpler form. Certain equations in mathematics are not in the form of linear equations, but they could be in the form of linear equations by performing some mathematical operations on them. After reduction of these equations in linear form, they can be solved and the value of unknown can be calculated easily. Reducing equations to simpler form. One example, n by 2 minus 3n by 4 plus 5n by 6 equals to 21. What is the LCM of 2, 4, 6? Here 12. Multiply both LHS and RHS with 12. Here n into 12 by 2 minus 3n into 12 by 4 plus 5n into 12 by 6 equals to 21 into also 12. Here 2 tables, 2 1 are 2, 2 6 are 12. Here 4 table, 4 3 are 12. Here 6 table, 6 2 are 12. Here no denominator here. Here 6 into n, 6n. Here 3 into 3, 9. Here 2 into 5, 10. So 6n minus 9n plus 10n is equals to 252. Here 6 minus 9 plus 10. So 10 plus 6, 16. 16 minus 9, 7n equals to 252. So here 7. So n is equal to 252 by 7. So 7 3 is 21. Here 4 remainder, 4 2, 42. 7 2 is 42. So n is equal to 36. Value of n is equal to 36. What is the method used here? Removing denominators by multiplying both sides of the equation and with LCM of the denominators. Okay, here no denominator is there because we use LCM to multiply. So remove denominators by multiplying both sides of the equation with LCM of the denominators. Reducing equations to simpler form. Solve x by 2 minus 1 by 5 equals to x plus 3 plus 1 by 4 plus 1. LCM of the denominators 2, 3, 4, 5 equals to 60. Multiply both sides by 60, both sides. So here 60 by 2, 30. Here 60 by 5, 12. Here 60 by 3, 20. Here 60 by 4, 15. Here 1 into 60, 60. Okay, 30x minus 12 equals to 20x plus 15 plus 60. Transposing 20x to RHS and 12 to LHS. So 30x minus 20x equals to 15 plus 12 plus 60 because 20x is plus. So transpose to LHS, it change minus 20x. 12 having symbol minus, so it transpose to RHS, it will change plus 12. So 30 minus 20, 10x, 15 plus 12 plus 60 equals to 87. So here 10 into x, so multiplication is there. So it transpose to right hand side as divided by 10. So 87 by 10, so 8.7. What is the method used here? Yes, place the value in the equation and check if LHS equals to RHS. What is the method used here? Same process. Remove denominators. Now you do check or verification if LHS equals to RHS. So x value, substitute x value or put x value in the place of x, LHS and RHS both. Reducing equations to simpler form. 3 of t minus 3 equals to 5 of 2t plus 1. Let's open the bracket. 3 of t, 3 into t plus minus minus 3 into 3, 9. So 5 of 2t, 5 into 2, 10 plus 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 5 into 1, 5. Next, transposing. Here 3t and minus 9. One is left hand side and another one is right hand side. Here 3t minus 10t. So 10t minus 10t here equals to 5 plus 9. So 5 plus 9 minus 70 equals to 14. So c is equals to 14 by minus 7. So 7 to the 14. So minus 2 is the answer. In this example, we brought the equation to a simpler form by opening brackets and combining like terms on both sides of the equation. So first we do using distributive property opening brackets and then transposing LHS to RHS or RHS to LHS. Place the value in the equation and check if LHS equal to RHS. Verification. So put t value at the place of t and check if LHS equals to RHS. Summary. In this lesson, we learned about reducing equations to simpler and linear form. The utility of linear equations is in their diverse applications, different problems on numbers, age perimeters, etc. can be solved using linear equations with one variable. Thank you children. P. Srinivas, SA Maths, ZPHS Rudwaram, Karimnagar.